Hey guys, welcome back to our channel. This channel, Aware Science, is all about trying to learn various concepts of data science by practicing a lot of questions. In this video, we are going to solve this question on Leetcode regarding find category recommendation pairs. The difficulty level of this question is hard, and I'm going to share the SQL schema as well as the Panda schema in the description box below. Okay, the question reads: we are given a table called product purchases with three different columns: user ID, product ID, and quantity. The combined columns user ID and product ID is the unique identifier for this table. Each row represents a purchase of a product by a user in a specific quantity. We are also given a second table called product info with three different columns again: product ID, category, and price. Product ID is the unique identifier for this table. Each row assigns a category and a price to the product. Okay. Amazon wants to understand shopping patterns across product categories. We are asked to write a solution to find all category pairs where category 1 is less than category 2. For each category pair, determine the number of unique customers who purchase products from both categories. A category pair is considered reportable if at least three different customers have purchased products from both the categories. We are asked to then return the result table ordered by customer count in descending order, and in case of a tie, by category 1 in ascending order lexicographically, and then by category 2 in ascending order. So basically by category 1 and 2 in ascending order. Okay, let's go through the example. It will make this clearer. So here we have product purchases table with various user IDs, IDs, and the quantity they bought this product in. And then we also have the info about that products, what category they belong to, and what is the price. Now let's look at, for example, product ID 101, 102, 201, 301. So this is user ID 1 who has bought four different products, and these four different products belong to electronics, books, clothing, and sports. Let's take one example of two categories: books and clothing. Let's see how many different people or different user IDs have purchased products from both these categories. So books and clothing, if we look at it, 102 and 201, user ID 1 has purchased that. If we look at user ID 2, so user ID has purchased four different products as well: 101, 102, 103, and 201. If we look at 101, 102, and 103, so two from books and 201 is clothing. So this user ID 2 has also purchased products from books and clothing as well. So right now we have two different people who have purchased products from books and clothing categories. Then let's look at user ID 3 as well. Four different products: 101, 103, 301, and 401. 101 is electronics, 103 is books, 301 is sports, and 401 is kitchen. So user ID 3 has purchased products from books category but not from the clothing category. Right? So user ID 3 is still not counted. User ID 4, 101, 201, 301, and 401. If we look at it, electronics, clothing, sports, and kitchen. Again, 4 is also not considered for us. Then for 5, 102, 103, 201, 202. So 102 is books, 103 is books, 201 is clothing, and 202 is also clothing. So 5 has bought products from books and clothing as well. So we have three people who have bought from categories books and clothing. So books and clothing should be in the output, and that is what we have, right? Books and clothing, three different people have bought it. So to solve this question, what we can do is, firstly, we can join these two tables, product purchases and the product info, so that we can get the category, and then we can proceed from there. So what we are going to do is, from this table called product purchases, let's alias this as P1. Let's perform a left join of the second table called product info, and alias this as P2. Let's join on P1 dot product ID is equal to P2 dot product ID, and let us return everything from P1. So select P1 dot star, and from P2, that is product info, we are only concerned right now about category. So P2 dot category column. Okay, let me go ahead and run this. Let's see what do we get in our output. So if you look at our output, we have all the three columns from the product purchases table, and then we have the categories. Now what we can do is, let's save this entire thing in a common table expression. So with CTE as, this entire thing goes into parentheses. And then what we are going to do is, we are going to do a self join of this common table expression on itself, such that for every user ID, let us find out all the combinations of the categories. So like in pairs. For example, you have user ID 1 who has bought products across 4 different categories, and you need to get pairs, right? So how many pairs that you can get? 4C2. 4C2 is combination. So 4 factorial divided by 2 factorial, 2 factorial, which is going to be 24 divided by 4, which comes out to be 6. Let's do that. It will become clearer. So what we are going to do is perform a self join. So from the common table expression aliased as C1, what we are going to do is, let us perform a left join or an inner join. It does not matter. Left join CTE as C2. And whenever you are performing a self join, you need to make sure that you give 2 different aliases to the same table. And then what we are going to do is, we are going to join on C1 dot user ID is equal to C2 dot user ID, and C1 dot category is less than C2 dot category. Why? Because we need to make sure that we are only, considering category pairs where category 1 is less than category 2. So basically, you should not have books, clothing, as well as clothing and book, because they represent the same combination, right? So that is why we are putting this here. Then what we are going to do is, let us return C1 dot user ID, then C1 dot category as category 1, and C2 dot category as category 2. Okay, let me go ahead, run this. Let's see what do we get in our output. So if you look at our output, we have for user ID 1, how many rows we have? 7 different rows, but one of them is null. So what we can do is, we are getting null category as well, right? In category 2. So what we can do is, we can filter them out that, hey, where your C2 dot category is not null. Let me run this again as well. So if you look at this output, so it's not ordered yet. Let me do this. Let me do the ordering by user ID, so that it's easier to explain and understand. So C1 dot user ID. So now what you see here is that if the user ID 1 has bought 4 different categories, the total combinations will be 4C2, that is 6. And if you look at it, you have 6 different rows, right? Electronic sports, clothing sports, books electronics, books clothing, books sports, and clothing electronics. So similarly, you get that for every user. Now it's simple. What we can do is, we can simply go ahead, group by category 1 and category 2, and then count the number of distinct users that have bought from that category combination. So what we are going to do is, group by C1 dot category, and then C2 dot category, and then what we are going to do is, return me C1 dot category as category 1, C2 dot category as category 2, and then what we are going to do is, we need to perform a count. Then count of distinct C1 dot user ID as what is required in our output. It's called customer count. Let me go ahead and count this. So it's not complete yet, because we still need to order, as well as not every of these combination is reportable. You remember in the question it says only those are reportable, only those combinations are reportable if at least 3 different customers have purchased the product. But let me go ahead and run this right now. Why did it fail? Remember, this is the basic mistake many people do. The order of execution is where group by then order, right? So you can simply remove this order by here from here, and it will run now. So what we have here is, we need the customer count for each of the categories, and you look, books clothing, we have 3 different, books electronics, we have 3, books kitchen, there is only one user who bought from these 2 categories, right? So once we have this, then we need to only keep those category pairs where at least 3 different customers have purchased the product. And basically what we can do is we can filter on an aggregate, that is group by, we grouped by C1 category and C2 category, and we can simply do having this count, right? So having this count is at least 3 or more, right? So having this greater than equal to 3, if I run this, it will only keep those rows where customer count is at least 3. Even though this says accepted, it's not complete yet. But if you look at it in our output, we have only those where you have customer count at least 3. Now the question says, finally, your results should be order by customer count in decreasing manner, and then by category 1 and category 2. So what you can do is you can write category 1 in ascending and category 2 in ascending. Okay, let me go ahead and run this. Let's see what do we get in our output. So yeah, now this is accepted. If we look at our output is exactly same as expected output. Let me go ahead and submit this to pass all the test cases or not. Okay, so this is accepted and this is how to do it. So yeah, tricky question. What we basically had to do in this was, firstly, we found out that, okay, for all of these product purchases, which category the products belong to. Then what we did was we performed a self join of the common table expression that we saved the results to in the previous part, so that for every user ID we can find out, okay, what are the pairs of product categories the person has bought from. Once we had that, we grouped by the C1 dot category and C2 dot category, so like both the categories or the pairs, and made sure that only those pairs where at least 3 or more people have bought from that pair is kept in our output. So yeah, this is how we do it. Let me know if there's a better, more efficient solve this question. Let the solution be in the comment section below, and I'll see you guys in the next video.